Welcome to lesson 5. In this lesson, we are going to look into built-in data structure supported by Python programming language.
In the previous lesson, we have seen how Python supports primitive data types that help in manipulating scalar data. In this lesson, we are going to look into Python's support for the manipulation of compound data. Python offers a few compound data types that can hold a collection of data values. The compound data types can be an ordered sequence of values or an unordered set of values. These compound data types are called data structures. The following table lists the built-in data structures supported by Python. The built-in data structures are: string, represent an immutable sequence of characters; list, represent a mutable sequence of values; tuple, represent an immutable sequence of values; set, represent an unordered collection of values; dictionary, represent an unordered collection of key-value pairs. These data structures are, in general, iterable in the sense that they support traversal and visiting the elements one by one. Let's look closer into the string data type. A string is a sequence of characters. Here are some characteristics of strings in Python. The data type name for strings is str. str is also a type conversion function that can convert any data values into strings. For example, str123 converts number value 123 to string value 123. Single-line string literals can be delimited using either single quotes or double quotes. Multiple-line string literals can be delimited using either 3 single quotes or 3 double quotes. For example, S6 is a 3-line string and 3 single quotes. Starts from here and ends here. Internally, a string is represented as a sequence of characters. For example, let's S be a string variable with value. Python is fun. The following table shows how S is stored internally as a sequence, or array, of characters. The first character, P, is stored at index 0. The second character, Y, is stored at index 1. The last character, N, is stored at index 12. In general, Python string index starts from 0 for the first character to index n-1 for the last character, where n is the number of characters in the string. The following table lists the common string operations. Note that the examples are based on variable s, which holds Python is fun as string value. Len. Len is a function applicable to all iterable data. For string, it returns the number of characters in the string. For example, len of s returns 13. Indexing, access to individual characters in the string, is by the square brackets. For example, s0 returns p. s12 returns n. Indexing can take a negative number. S-k returns the k character in S from the right-hand side. For example, S-1 returns the first character from the right-hand side. S-13 returns the 13 character from the right-hand side. Concatenation. The plus operator is overloaded to represented string concatenation, which combines two strings into one. For example, S plus concatenate S with exclamation mark and return Python is fun. Multiplication. Self-concatenation of a string with itself many times, such as S plus S plus S plus S plus S, can be simplified to S5. Note that S5 does 5 to 1 equals 4 times self-concatenation. String methods. Counting. S.count of S1 counts the number of times the substring S1 appears in S. For example, S.count of n returns 2. Starts with S.starts with of S1 returns true. If and only if The substring s1 is a prefix of s. For example, s.startSwith of pi returns true. InSwith s.InSwith of s1 returns true. If and only if. The substring s1 is the suffix of s. For example, s.InSwith of fun returns true. Lower. Return a new string where all characters in s are converted into lowercase. For example, s.lower returns Python is fun. Upper. Return a new string where all characters in s are converted into uppercase. For example, s.upper returns Python is fun. Split. Return a list in which the string s is split into substrings according to specified delimiter. For example, s.split returns Python is fun based on the delimiter space character. Let's do some experiments with string operations. Write the above string operations in a Python file and run it. Note, the backslash in the last print statement is used as a continuation character, allowing a statement to spill into the next line. You should pause this video for the exercise. These are the expected outputs from the experiment. Here are the codes and outputs on one screen. You should pause this video to study the codes and the corresponding outputs. Note that strings are immutable objects. We can't change contents of a string object. In the above statement, we try to change the first character in the string, and the system complains. str object does not support item assignment. Let's look closely into the list's data structure. Lists are a versatile data type in Python. It is used in almost all practical programs. List literals can be written as a list of comma-separated values enclosed in square brackets. Members of a list need not be of the same type. List indexing is similar to string indexing. The first member has index 0, and the last member has the index n1, where n is the length of the list. Characteristics of lists in Python. The data type name for lists is list. List is also a type conversion function that can convert other compound values into lists. For example, list1b2 converts the string into a list of individual characters, 1, b, 2. Lists and arrays. Lists can be used to simulated one-dimensional arrays or two-dimensional arrays. A 1D array is simply a list of items, scalar or compound. For example, list 1D equals physics, chemistry, mathematics. A 2D array can be simulated by a list of items. For example, list 2D represents a 3x4 matrix as a list of 3 sublists, where sublist 1 equals 1, 2, 3, 4. Sublist 2 equals 5, 6, 7, 8. Sublist 3 equals 9, 0, 1, 2. Indexing. To access any member in a list, use the square brackets with the index or indices to obtain element at that index. For example, list2d, 1, returns the first element, which is the first sublist, 5, 6, 7, 8. List2d, 1, 2, returns 7, which is the second element of the first list of list2d. Essentially, list2d, 1, 2, represents the element at row 1, column 2, in the 2D matrix. List1d-1, return the first element from the right side, or the n side, which is mathematics. Note: list1d-1 returns list1d-n, 1, where n is the length of the list. Slicing. To access a part of a list, use the square brackets with slice object. Slice, start, stop, step. For example, slice 2, 10, 3, specifies a slice object that chooses part of the list start from index 2 up to index 10-1. Step 3. This slice object can be applied to a list. For example, let A equals 20, 21, 29. Then a slice, 2, 10, 3, returns the elements in at position 2, 2 step 3 equals 5, 5 step 3 equals 8. In a list, 22, 25, 28. Slicing using start: stop: step operator. Alternatively, instead of using the slice object, slicing can be done using operator and square brackets to separate the start, stop and step values. Example: a 2, 10, 3 returns the same slice from list A. In slicing a list, or string, or tuple, T, the default values are as follows. If the start value is not specified, it defaults to 0. If the stop is not specified, it defaults to len T. If the step is not specified, it defaults to 1. If the step value is negative, it means step from right to left. The following table shows common list operations. Assuming that T is this 13-element list. Len function. Len T returns the number of elements in T. For example, len T return 13. Indexing. Tk returns the k+1 element in T. For example, T0 returns 1, and T12 returns 3. T-k returns the k character in T from the right-hand side. For example, T-1 returns 3. T-13 returns 1. Concatenation. Combine two lists into one. For example, T plus 3, 4 returns the combined list that contains 15 elements. Multiplication. T time k performs self-concatenation, k-1 times, and returns the resulting string. For example, T time 5 performs self-concatenation 4 times, and the returned value is the same as T plus T plus T plus T plus T. Membership in operator. Check whether an element is in a list. For example, 4 in T returns true. Max function. Return the maximum element in T. For example, max T returns 9. Mean function. Returns the minimum element in T. For example, mean T returns 0. The last three operations are list modification methods. Append method. Append an element to a list. For example, T.append 6. Appends element 6 to the list T. T contains 6 as last element after append. Pop method. Removes and returns the last object from list T. For example, T.pop. Return the last element, which is 6. The last element in the list disappears after pop. Insert method. Insert an element into a list at particular index. For example, T.insert 2, 4. Inserts element 4 into list T at index 2. 4 becomes the element at index 2 after insert. Let's do some experiment with list operations. Write the above list operations in a Python file and run it. You should pause this video and do this exercise. These are the expected output from the experiment. These are the combined codes and outputs. You should pause this video and study the codes and corresponding outputs. Lists can be manipulated using indexing and slicing. Instead of the list modification methods. Updating a scalar element. For example, list_d, 2, equals biology. The statement changes the element of list 1d at index 2 to biology. Results, list 1d becomes, physics, chemistry, biology. Updating multiple elements. For example, list2d, 1:3 equals x, y. Changes the element of list2d at slice, 1:3. In the first sublist to, x, y. Results, list2d becomes first row, 1, 2, 3, 4, second row, 5, x, y, 8, third row, 9, 0, 1, 2. Tuples. A tuple is similar to a list, except that it is immutable. The contents of a tuple stay constant after the tuple is created. Creating a tuple is identical to creating a list, except that the square brackets are replaced with round brackets. Tuple supports indexing and slicing, using square brackets with the index or slice objects. Sets. A set is an unordered collection of elements. Set literals use curly brackets to enclose the comma-separated elements. The characteristics of sets are summarized below. The name of the data type for sets object is set. Set is also the conversion operator that converts other compound data type to set data type. No repeated elements can appear in a set. A set is mutable but the elements in the set are immutable. Sets do not support indexing or slicing, as there is no index attached to set elements. Standard set operations are union, intersection, and difference. Dictionaries. A dictionary is an unordered collection of key-value pairs. Dictionary literals use curly brackets to enclose the comma-separated key-value pairs. The characteristics of dictionaries are summarized below. The name of the data type for the dictionary's object is dict. A dictionary object can be created by using literals, the dict constructor or the dict.fromkeys method. Value-oriented data retrieval. While lists and tuples support index or position-oriented data retrieval, dictionaries support value-oriented data retrieval. For index-oriented data retrieval, we provide an index to a list or tuple to return the data stored in a particular index. For value-oriented data retrieval, we provide a key to a dictionary to return the value corresponding to the particular key. Let's do some experiments with dictionaries. Write the above operations in a Python file and run it. You should pause this video and do the exercise. These are the expected output from the experiment. Here are the combined codes and outputs. You should pause this video and study the codes and the corresponding outputs. This is the end of Lesson 5. Thank you for your participation.